Hello everyone, this is Venugopal. Today in this session, we'll see the decorators in Python. Decorators are very powerful tools. It acts like a tool, powerful tool. Now these decorators basically, these are used to modify existing existing function without changing its basic structure. You can say that basic structure. You can say that it is used to add more functionalities, more functionality to the existing code without changing the code. That means ultimately it is used to what? Reduce your code. It is used to reduce your code, or you can say that it makes your code smarter. Rather than creating adding a more code, it will create your existing code more smarter. Okay, so basically whenever we are talking about this decorator, if this is a decorator tool, let me change the font. Suppose this is a decorator tool, right? Let us understand this is a decorator tool. So what this decorator tool will take as a input? It will take input as a function. It will take function as an input. This function will give a input to this particular decorator. In this decorator, it will add some functionalities. In this tool, it will add. Let me increase the size. Okay, add functionalities to what? To input function. Whatever the function we are giving input to this, it will add the functionality. And after adding the functionality, it will give the output, and that output will be the function. It is obviously it is an output function with additional functionalities. That means we are giving, suppose, a raw input function. This is a raw input function to this particular decorator. This decorator will add some more functionality, and as a output we are getting what? The same function but with some additional functionalities. Okay, so this the complete setup is called as a decorator. It's like a decorating something which is already existing. Okay, so we'll try to understand this concept through one simple program. So let us consider I'm defining one function, suppose lecture. I'm taking one function as a lecture, whereas it is taking one argument name, and simply I'll print the message. Whatever the name is there, the name of the professor, I'm giving the will take lecture. It's very simple code, right? I've defined one function, right? And I'm passing one argument. So how to call this function? Simply I'll call this function by taking the function name, the take lecture, and suppose I'm passing, suppose Ajay is taking a lecture. Now if I'll execute this function, okay, lecture is a function which is taking one argument. This argument will be captured over here, and this will print the message, and you will get the output like this. It's a normal function. We are not at all doing anything extraordinary, right? It's a simple program. Okay, what happen if I'll pass one more argument, control C, control V, and this time in place of Ajay, I am taking Vijay. If I'll execute, you will get two outputs. One is Ajay will take lecture or Vijay will take lecture. So let us understand, this is a normal function, right? Whatever the argument I am passing, it is going to execute this lecture function. Now this is already existing function. Now you suppose I want to add some functionality to this existing function. What is that functionality? Suppose if any other person is coming, for example, named with Venu, that's my name. Okay. Suppose if I'm passing the argument as a Venu, then I don't want to execute this statement or this output. I want some different output. Whenever the input is coming as Venu, right, parameter, I want to execute the say different output. So for that purpose, what we will do, we'll define one decorator. Okay, so how to define a decorator? Simply just like a function, define. For example, I'm defining one decor. It's a decorator function. Now, as we have seen here, what this decor function is taking, it is taking input as what? Input as a function. So parameter must be what? Function. So here I will pass what? Any argument. I have given the name as func, F-U-N-C func. Inside this, now I have to create one exact replica of this. Okay, so what I'll do, I'll define one inner function here. Inside this inner function, I am passing the same argument what this function is taking argument, because it is a replica of this. Okay, so here what I'll do, I'll put a one condition. If the name will is equals to suppose my name Venu. If it Venu comes as an argument, okay, so I want to execute this particular block. Okay, instead of executing this block, I want to execute this block. What is that block? Print. I want to write a message like name, comma, will deliver. I will write deliver the lecture. Deliver the lecture. I want to execute this. If Venu is not the argument, else, so I want to execute as it is. So what is the name of function here? Function is the name of the function because I have redefined that, and name is the argument. And finally, what I'll do, I'll return this inner function. This is my decorator. For which function? This function. Now this function is exactly replaced by this function. Okay, so I have created one decorator for my existing function, right? What existing function does, if any argument is coming, it will executing this, right? The statement. But I want now another function. For example, if I'm passing suppose lecture as a name Venu. So whenever the argument is Venu, I don't want to execute this function. I want to execute this function. That is the concept called as decorator. But if I execute right now, will it make any changes or will it give the same output like Ajay, Vijay and Venu will take lecture? Let us check. So it is executing this one only. It's not executing the decorator. It is executing this statement only. Why? Because we have not linked this decorator with my existing function. So if I want to link this one with this function, we have to use what? Decorator at the rate of, I have to use like decor. We need to give the name of the decorator. The name of the decorator is what? Decor. Decor. After simply adding this annotation, now what happened? If I'll remove this one, observe carefully. Every time now, whenever I'll execute this program, whenever this lecture function will be called, before executing this lecture function, it will execute this one. For example, lecture, it will call the function lecture Ajay. So instead of executing this function, it will go this one and it pass name here Ajay. Is Ajay equal to Venu? No. So it will comes to the else part and it will execute as it is this function name. That means what? This function. And you will get the output what? Whatever be the name is there, Vijay, Ajay, it will execute, will take the lecture. Check it out. You are getting the same output. But the moment when I'll pass input as a argument as Venu, now observe carefully. Now what happened? Every time this function only execute. Now whenever you are passing Venu, what happened? This time it will go there. It will check. Okay, it is matching with this Venu argument. Then what it will do? It will execute this line instead of this line. So here the line is what? This name, that means Venu will deliver the lecture now. It will not execute Venu will take the lecture now. Right? Just check it. Now you see the third one, third line, Venu will deliver the lecture. So every time now what happened? This is called as a decorator. So decorator has taken the input as a function, applied some modification, right? And executing the extended function. This is my extended functionality of the same function. So always, so whenever you are putting this decorator here, the annotation here, every time this function is not going to execute. Before this execute, it always execute the decorator first only. Now, what if I don't want to execute this decor every time? Then you can also define like manually. How to define manually? How to call the manual function? Instead of this, you will do one thing like I'll define one dec function is equals to decor, and I will pass my function name, that is lecture. So what happened here? Here I'm explicitly I'm calling, not automatically call takes. Like if annotation, if I'll put annotation, it will take automatical call to the decor function. Now it is not going to happen like that. What happened? I'm explicitly calling now. Okay, so whenever I'll call dec function, then only the decor will execute. Otherwise, if I'm not calling here, then it is not going to execute this one. Now observe carefully. If I'll execute the same output, you're not going to get now when you will deliver the lecture. It will execute this only, this part only. Observe carefully. See, it is not executing the above decorator function because here in the bottom line, I have not called anywhere this dec function. I hope you're getting. If I want to call, what we need to do? We need to explicitly call dec fun in the bracket. Now I need to pass Venu. So this is called as a manual calling of the decorator. If I'll execute this now, you can observe now this is calling the decorator function. So there are two approaches. One is by the using the annotation, like just you have to put the annotation just above that function for which you have applied the decorator, or else by using this one manually also you can call. So for the moment, I'll comment this and this also, so that you will be having both the codes. And I'll put like here a comment. It's a manual calling decorator. And here at the rate decor, that means what? Every time before executing this function, now it always execute the decorator. If I'll execute this, you will get this one. So I hope you are getting what exactly mean by decorator. Decorator is a specific, it's a powerful tool which is used to modify the existing functions, right? So that it will have the output with some extended functionalities. Okay, so that's it. It's a very simple concept. I hope you have understood. For this video, we will stop here. For more videos, keep watching. Till then, bye bye.